Hey folks, this is Mr. Ward again. Welcome to Unit 8, Linear Programming, Day 3. I have 4 problems. I'm not sure if we're going to do them all. They do take some time. We'll see what we can do. I don't want to make 4 15-minute videos for you guys to have to watch. I might just put it up there, the results, and then you can take a look at it and not have to go through the whole thing with me. All right, so let's do this one, a quick one. PKJ Company produces 2 types of notebooks, a 5-subject and a 1-subject. The company can produce no more, or at most 600 notebooks per day with no more than 205 subjects. The profit on a 5-subject is $3. The profit on a 1-subject is $1. Nice one for you to start with. This could maybe even be a little warm-up for you. See what you can do. Declare the 2 decision variables. X equals number of 5-subject. And y equals number of 1-subject notebooks. There we go. All right. Constraint inequalities. No more than 255, no more than 205 subjects, so X is less than or equal to 200. And they can produce at most 600, so X plus Y is less than or equal to 600. Those are going to be the 2 we're going to graph. Let's go down here. Let's put our axes on. Let's go here and here. And don't forget this is 5 subject. And this is 1 subject. And we're going to go by 1,000. So we can label our X and Y axes a little bit easier. All right, if we go by every 2 boxes is 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Again, thousands. 6,000, 6,000 would be the intercepts for that one. And no greater than 2,000 would be a vertical one here. We would shade below this and to the left of this, hence making this our feasibility region. I see 4 corners, P1, P2, P3, P4. Our profit function that we're going to plug into. 3x plus 1y profit equals 3x plus 1y. What's P1? 0, 0. P2, 2, 0. P3, 2, 4. And P4, 0, 6. If I've plugged them into that profit equation, I would get 3 times 0, 1 times 0. I'm just going to speed things up a little bit. 3 times 2,000 equals 600. Pardon me. 3 times 2,000. Oh, sorry, that's not times 1,000. That's where I was off. Times 100. My bad. I'll fix that on my graph in a minute. 3 times 200 is $600. 3 times 200 plus 1 times 400 equals 1,000. That's the best so far. And 3 times 0 plus 1 times 6, oops, $1 times 600 equals $600. Optimum would obviously be 0.3. So to answer that question, again, a nice one to get started with. So we already wrote our profit equation. P equals 3x plus 1y. make 200 5 subject and what was our other number? 400 1 subject for max profit of $1,000. Let me go back up and fix this. My graph should have said 100, not 1,000. And the same goes here. All right, nice one to start with, I thought. Pretty easy constraints. Not many of them, easy to find, easy corners, easy vertices. Probably could have answered that question actually without using this linear programming process, but again, focusing on the process itself. All right, example number 2, making automobiles, either cars or trucks. It says automobile manufacturer could make cars and trucks in a factory divided into 2 shops. Shop 1's assembly, shop 2 is finishing. Shop 1 performs basic assembly 6 person days on a truck, but only 3 person days on a car. Shop 2 finishing 4 each, truck or car. Because of personnel and machine limitations, assembly shop has 150 person days per week available. Finish shop has 120. To manufacture a truck, you profit $500. You profit $350 on each car. How many of each should be produced in a week to maximize profit? So we're about a third of the way through the video. Again, let's see if we can get through 3 questions. X equals number of cars made, and Y equals number of trucks. All right, I'm going to use that grid setup I did the other day. X, Y total. X, Y total. Cars, trucks total. And then assembly shop. Shop 1. Shop 2. Finishing shop. If I fill in the grids, cars, assembly, finish. 3, 4. Trucks, assembly, 6, finish. 4. Max, 150, 120. I now have 2 inequalities, which are 3x plus 6y is less than or equal to 150, 4x plus 4y, less than or equal to 120. Let's use our x-intercept, y-intercept method. 150 divided by 3 is 50. 150 divided by 6 is 25. 120 divided by 4 is 30. 30. So we have our intercepts. I think we can label our axes now. Here's X, here's Y. I think if we go by 5s, 10, 20, 30, 40, 50, 60. Remember that's cars, trucks, 10, 20, 30, 40, 50, 60. All right, what are our intercepts? Let's do our assembly in blue. Let's do our finishing in black. Blue has an x-intercept of 50, a y-intercept of 25. Blue has an x-intercept of 50, a y-intercept of 25. Let's connect them with a nice blue line. Black has intercepts of 30 and 30. Again, a nice line. And it's down and down. So our feasibility region would be right in here. And I see 4 corners. I see the corner here, 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 and here. All right, so what do we got? P1 is the origin. P2 is all cars, and I could make 30 of them. P3 is that combination of the two. It looks like 10, 20 to me. I will check it, solving the system in a second. And if I can make all trucks, I can make 25. And let's go back to our question. What are we looking to do? We're looking to maximize profit. So we need an objective function, profit. Profit equals 350. That's a weird 3. 350 on a car and 500 on a truck. Let's go back to solving that system of equations to find that point 3. I'm going to take these two. I got them right there. I'm going to set them up. I'm going to multiply blue times -4. I'm going to multiply black times 3. Get the x's to drop out. -12x minus 24y equals, what's that, -600. Equation 2, 12x plus 12y equals 360. X's are gone. -12y equals -240. Y would equal 20. Plug it back into this one. 4x plus 80 equals 120. 4x equals 40. X equals 10. How did I do? 10, 20. Was my graph pretty accurate? Yes, it was. But I verified that, especially when the scale is large and it doesn't meet on a nice, easy intercept. All right, so let's plug everything into profit. Got to show all these steps. P, 350 times 0, 500 times 0. I know, take some time, but 350 times 30, 500 times 0. That is $10,500. 350 times 10, 500 times 20. That is 13,500. And the last one, 350 times 0, 500 times 25 is 12,500. We're looking to maximize our profit, which would be this one right here. And let's answer our question. Maximum profit of $13,500 by making 10 cars and 20 trucks. All right, that's 2 problems down. We're about 13 minutes into the video. Great place to call it. I'll make another video and we'll do either 1 or 2 more. All right, guys, great work. We'll talk to you soon.